Good morning, students. Here we are again meeting with the part 2 chapter, that is combustions and flame. We have already completed with the part 1. In that, we have studied what is combustion, the types of combustions, combustible and non-combustible, right? Today, we are going to start with the topic, that is types of combustions. There are three types of combustions. One you can see, that is rapid combustion, spontaneous combustion, and the third one is explosion. So these are the three types of combustions. They are classified into three categories: rapid combustion, spontaneous combustion, and the last is explosion. Let's see what is rapid combustions. Okay, before that, I would like to know, during a burning matchstick or a gas lighter near a gas stove in the kitchen, and you turn on the knob of the gas stove, what do you observe over there? What do you observe? You will find that the gas burns rapidly, right? And produces heat and light. Yes or no? When you see the gas stove burns very rapidly, means it takes suddenly it start burning and produces heat and light. Such combustion is known as rapid combustions. You can see the combustions in which a substance burns rapidly and produces heat and light is called rapid combustions. There are substances like phosphorus which burn in air at room temperature. So this is a white phosphorus, but and this is the example of rapid combustions. Burning of white phosphorus at room temperature is an example of rapid combustions. Okay, the second type of combustion is spontaneous combustion. The type of combustions in which a material suddenly bursts into flames without the applications of any apparent cause is called spontaneous combustion. So, what is spontaneous combustion, students? The type of combustion in which a material suddenly bursts into flames without the applications of any apparent cause is called spontaneous combustion. Now, what is spontaneous combustion? Spontaneous combustion is, for example, coal dust. They has resulted in many disaster fires in coal mines. You can see here, this is spontaneous combustion of coal dust in coal mines. They have resulted many disastrous fires in coal mines. Spontaneous forest fires are sometimes due to the heat of the sun or due to lightning strike. You can see here, this forest fires caused by spontaneous combustion. How? It is due to the heat of the sun, or you can say due to the lightning strike. So most forest fires are due to the carelessness of human beings also. When we can say about that also, how it is. See, it is very important to remember that The campfires must be completely extinguished before you leave from the forest after a picnic or a visit. It has to be, remember, whenever we leave from that spot, if there is any campfire we have done, we should extinguish that campfire first and then we have to leave. Otherwise, what happens there? It can cause disasters over there, isn't it? This is what the spontaneous combustions. Okay, examples you can write, the forest fires and the coal dust which causes disasters in the coal mines. Okay, so generally we have fireworks on festival days, yes or no? Diwali, we used to, what we used to do, we used to fire the crackers, yes or no? So when a cracker is ignited, a sudden reactions take place with the evolutions of heat, light and sound, yes or no? A large amount of gas formed in the reaction that is liberated. Such a reaction is called explosion. Okay, when a cracker is ignited, okay, when the cracker is in a, there is a sudden reaction taking place, and with that reactions it evolves the heat also, light and even the sound also, yes or no? When you fire the crackers, it will, first you will heat that, first you will put the fire, then it spark the crackers sparkles, right? Then what happens? The sound produces, isn't it? So when there's sudden reaction taking place with the evolution of heat, light and sound, a large amount of gas is formed in the reaction that is liberated, yes or no? That liberated one is, such type of reaction is called as explosion. Explosion can also take place if pressure is applied on the cracker. When you applied a pressure on that cracker, it will explode. Okay, so example you can write, burning of crackers is example of explosions. Next topic is flame. Now what is flame? Flame is a zone of combustion of a combustible substance. Students, some substances burn with a flame while others burn without flame. Okay, some substances will burn with a flame and while others burn without a flame. See, different flame burns with different colors. Yes or no? They burns with the different colors. Now for example, if you take a matchstick, okay, matchstick burns with a yellow flame, and whereas LPG flame जो है, that burns with a blue flame. Have you seen that? Have you observed that? Matchstick, when you burn it, it will burns with a yellow flame, whereas LPG flame burns with a blue flame. Okay, so here the substances which vaporize during burning produces flames. It will produce flames when the substance is going to get burned. And for in that we can write the example, kerosene, wax, etc. See, during magnesium ribbon that burns with the dazzling white flame. We have learned this, yes or no? So here the examples which we have given, kerosene and wax. Kerosene lamp has a yellow, you can see this is a kerosene lamp. This has a yellow and smoky flame. They have a very smoky flame, but one thing is that it has a blue and smokeless flame when they burn in a stove. You can see the glass is there. When the glass is kept in that, and if you burn that, there is a blue color and the smokeless flame will burn in that stove. Now substances which do not vaporize during burning do not produce flames. Okay, these substances which do not vaporize during the burning, they do not produce flames. For that, you can write the example coal, charcoal and etc. Okay, so flame is a region where combustion take place. Listen carefully. Flame is a region where combustion take place, and the color of a flame depends upon what? They depends upon the temperature. They depends upon the amount of available oxygen and the nature of the combustible substance. Okay, this flame, they are going to depends upon the temperature, amount of available oxygen and the nature of the combustible substance. Understood? Only solid and liquid fuels which vaporize on heating, they will burn with a flame. Only solid and liquid fuels which vaporize on heating burn with a flame. Example I told you, kerosene and wax. Kerosene is in a liquid flame, a liquid fuel. Wax is a solid fuel. When they both vaporize during burning, they form flames. What they form? They form a flames. Whereas charcoal or coal does not vaporize and hence does not burn with a flame. They do not vaporize, right? You can see the flame, but they are not vaporizing over there. No gas is evolving over there. So all gaseous combustible substances burn with a flame. Understood? This is what about the flame. Flame is a zone of combustion of a combustible substance. There are two types of flame. One which vaporize during burning, they produces flames, and other which do not vaporize during burning, do not do not produce flames. Okay. See, here substances which give out flame. As I told you, the substances which vaporize during combustion or during burning, they give flames. Example, kerosene, wax burn with a flame, whereas charcoal on the other hand does not vaporize and so does not produce a flame. Okay students, understood what is flame? The substance which vaporizes during combustion gives flames, whereas which does not vaporize, they do not produce a flame. Next is different zones of candle flame. There are zones of a candle flame. A candle flame has 3 different color zones. They are dependent on the amount of oxygen which is available. Okay, so let's see what is the structure of this candle. You can see here the figure which is shown in this. This is a candle. When you burn the candle, it shows 3 different zones. You can see one which is innermost zone, second which is middle zone, and the third is outer zone. You can see outer zone of this candle flame. It complete combustions. It is completely taking a combustion is taking place. And here outer surface, you can see in this figure you are not able to see the color. It is, but when you see the outermost color of this flame, it is blue in color. Okay, it is blue in color. And the middle zone, they are partial combustions, means partially it is burning, and its flame is yellow in color. Innermost zone of unburned wax, they are black. You can see it is in center, it is black in color. Okay, so which part is most hottest part? You can see that is outermost, or outer zone is the hottest part, and the middle zone is a moderately hot, and the this innermost zone, that is least hot. And this is what the candle which is made of wax. Okay, so outermost zone, which is in blue color, this is the hottest part of the flame. This is the hottest part of the flame. This zone emits very little light. It emits very little light. In this zone, wax undergoes complete combustion. Why? Why it is completely combustion? Because there is a plenty of oxygen around it. Okay, there is a plenty of oxygen around it, so this wax undergoes complete combustions. Understood? Next is middle zone. This zone is bright yellow and luminous. It is less hot than the outer zone. It is moderately hot, means less hot. Okay, it is less hot than the outer zone. Here there is an incomplete combustion, means partial combustion is taking place of water vapors due to low oxygen. Carbon particles are produced over here, and these zones emits most light. This zone emits what? They emits most light. The third zone is innermost zone. This is the dark zone. You can see it is black in color. It is the coolest part of the flame, since oxygen is not available in this zone. Okay, oxygen is not available in this zone, so there is no combustion taking place over here. The zone is dark and emits no light. Why? Because there is no oxygen. Understood? If there is oxygen, then only it going to take place, the combustion is going to take place. But in this zone, there is no oxygen, so no combustion will take place. And the zone is dark, so it emits no light. Understood? So this was the different zones of candle flame. Now you will understand why this goldsmith used the outermost part of the zone. They use a metallic blowpipe for melting gold and silver in the outermost zone of a flame. What they used to do? They used mostly the outermost zone of the flame. Understood? To for melting gold and silver. This goldsmith blow the outermost zone of a flame with a metallic pipe. You can see this is a blowpipe for melting the gold and silver. Okay. Now, students, we have already learned about the fuel. Yes or no? In the previous chapter, we learned about the fuel. What is fuel over here? Okay, it is some qualities about, we learn some qualities about good fuels. Yes or no? Substances that produce heat and light on burning, like when you burn wood, charcoal, petrol, kerosene, right, etc., etc. They all are what? They all are fuels, because the substance, they produce what? They produce heat and light, right? So they are called as fuels. And we learned the good fuels also. That is, good fuel is one which is easily available and very cheap. Yes or no? And that is easy to store, transport, and handle. Then it burns easily in air at a moderate rate. Then it is also produces large amount of heat. Fuel produces large amount of heat. That fuels does not produce any poisonous and irritating fumes during during burning. Okay, this fuel does not produce any poisonous and irritating fumes during burning. Fuel leaves no ash on burning. They do not leave any ash. Ash, rock, anything. If you burn that wood, when you burn, after that you get the rock. That is what? Ash. Okay, they will not produce any ash on burning. What you have to remember in this, that there is no fuel which can be considered as an idle fuel. Understood? There is no fuel which can consider as an idle fuel. You know which are the fuels? Their fuels can be grouped into solid, liquid, and gaseous fuels. Yes or no? We have seen that also. What are solid fuels? Solid fuels are those: coal, coke, cow dung, wood, charcoal. These are the examples of solid fuels. Then we learned about the kerosene fuels. Liquid fuels. What are they? Kerosene, petrol, and diesel. Then we learnt about the gaseous fuel. What are the gaseous fuel? Natural gas, LPG, coal gas, biogas, and petroleum gas. Understood? These are the types of fuels. Now in this, the efficiency of a fuel is, they are mainly decided by the amount of heat which is releases on complete combustions. Okay, complete combustions and of its 1 kg of fuel, and this is known as the calorified value of the fuel. Means here that efficiency of fuel which is decided by what? By the amount of heat which is released. When it is released, when it completely burns, or when it is completely combustions, means combustion is taking place. It's 1 kg of fuel, and that is known as the calorified value of the fuel. You can see calorific value. The standard unit of representing calorific value is kilojoule per gram or per kilogram. Okay, so the amount of heat energy produced on complete combustions of 1 kg of a fuel is called its calorific value. The calorific value of a fuel is expressed in a unit called kilojoule per kg, or you can write kj sorry, kj per kg. Okay, you can see here different fuels which having different calorific values. These are the fuels which are used and their calorific values is given here. Cow dung cake is nearly 6,000 to 8,000. Wood value is 17,000 to 22,000. Coal is 25,000 to 33,000. Petrol, kerosene and diesel, they have the value is 45,000. The methane is 50,000. CNG also having 50,000. And LPG, biogas, hydrogen, like that the values goes on. Understood? This is the calorific value of different fuels. Next we will see what are the disadvantages of burning fuels or burning of fuels which leads to harmful products. Okay, here the increasing fuel combustion has harmful effects on the environment. Yes or no? When the increasing fuel, when you consume it, right, it has very harmful effects on the environment. The fuel which is consumed, that also increased with harmful effects. Yes or no? Even with the increase in populations, right? So carbon fuels like wood, coal, petroleum, they releases unburned carbon particles. These are pollutants and cause respiratory disease. Carbon fuels, what are the carbon fuels? Like wood, coal, petroleum, they releases unburned carbon particles. Yes or no? So these fine particles are very dangerous pollutants and they can cause respiratory diseases such as asthma. Okay, such as asthma. Secondly, incomplete combustion of these fuels gives carbon monoxide gas, CO. It is a very poisonous gas. It is very poisonous gas. It is dangerous to burn coal in a closed room. Okay, the carbon monoxide gas which is produced, they can kill people who inhale this gas. That's why we are not advised that never sleep in a room with the burning or smoldering coal fire in it, because when the wood is burning over there, that time what is producing? Carbon monoxide gas is producing, and that carbon monoxide gas, when it produce, it can kill the persons when they are sleeping in that room. Okay, so better don't fire anything when you are in sleep. Next is, third point is, combustions of most fuels releases carbon dioxide in the environment. Okay, the combustion of most fuel, they releases what? They releases the carbon dioxide in the environment. This increased concentration of carbon dioxide in the air is believed to cause what? Global warming. This increased concentration of this gas, they leads to global warming. Okay, what is global warming? Global warming is a rise in temperature of the atmosphere of the earth. Okay, next advantages of burning fuel is, burning of coal and diesel releases oxides of sulfur. Okay, or sulfur dioxide gas. Sulfur dioxide gas is an extremely suffocating and corrosive gas. Petrol engine gives off gaseous mixture of what? Of nitrogen, right? So oxides of sulfur and nitrogen, when they dissolve in rainwater, they forms acids. When the sulfur and nitrogen, when they dissolve in rainwater, they forms acid. Such rain we called as a acid rains. This acid rain is very harmful for crops, buildings and soil. You have learnt in the previous class, yes or no? So the uses of diesel and petrol as fuels in automobile is being replaced by what? By CNG. What is CNG? CNG is compressed natural gas, because CNG produces the harmful products in very small amounts. So CNG is a cleaner fuel. Yes or no? CNG we have learned in this in the last chapter. CNG is a cleaner fuel. As I told you, what is global warming? Global warming is the rise in the temperature of the atmosphere of the earth. This results in the melting of polar glaciers, which leads to rise of the water in the sea. Low-lying coastal areas may even be submerged under water. So here we ends with the with this chapter, that is coal and combustions and flame. Okay, so students, I request that you read this chapter, okay, and understand what is given in this chapter. What you have learned in this chapter: the substances which burn in air that we called as a combustible. This has been done in the part 1 video, right? The substances which burn in air are called combustible. Oxygen, which is present in air, it is very essential for combustion. Without oxygen we cannot produce any flame. Yes or no? So during the process of combustion, heat and light are given out. Then we learned about the igneous temperature. What is igneous temperature? It is the lowest temperature at which a combustible substance catches fire. Then inflammable substance. What are inflammable substance? They have very low igneous temperature. Fire can control by removing one or more requirements which is essential for producing fire. What are the fire extinguisher? Water. Water is commonly used to control fires. Other one is water cannot be used to control fires involving electrical equipments or oils. Okay. These are various types of combustions, such as we have types of combustion right in this video, that is rapid combustion, spontaneous combustion and explosion. Then we learned about 3 different zones of a flame. It have dark zone, luminous zone and non-luminous zone. Then we learned about good fuels. An ideal fuel is a cheap. They are readily available, readily combustible, right? They are easy to transport. It has high calorific value. It does not produce gases or residues that pollute the environment. Then fuel differs in their efficiency and cost also. Fuel efficiency is expressed in terms of its calorific value, which is expressed in units of kilojoule per kg. Right? Then unburned carbon particles in air, they are very dangerous pollutant causing respiratory problem, that is asthma. Then incomplete combustion of fuel gives poisonous carbon monoxide gas. When you inhale that gas, it will kill you, right? Then we learn the increasing percentage of carbon dioxide in air, and it has been linked to global warming. Yes or no? And the oxides of sulfur and nitrogen, they produce by the burning of coal, diesel and petrol. And what they cause? They can cause acid rain, which is harmful for buildings, crops and soil. Hope that students you understood this chapter. Okay, then you have to do the exercise of your textbook, page number 75. I repeat, page number 75, exercise of your textbook. You have to write in your rough book, or if you have made a science notebook, you can write in that the conditions under which combustion can take place. Or listen the question carefully. List some conditions under which combustion can take place. Then filling the blanks which is given in your textbook, you have to find the answer. Okay, for that you have to read your chapter, then only you will be able to write the answer. Okay, after that I will give you the question answers in your workbook. Okay, till then, take care, have a nice day. Thank you.